Okay, welcome. So today we will be discussing some security issues and some threading issues related to Android programming. And I gave a task for searching how to find a way to update the UI thread from a background process. And one of the suggested solutions is to use run on UI thread. This is the most common way of doing that. So the activity has a method called run on UI thread, and then you pass a runnable into it, right? And then it will be put into the queue using the handlers, but you don't have to deal with the handlers manually. It will kind of do that for you, and will execute the code in the UI thread. So then you can update the UI. And as you see, it will be a little bit awkward for me to be editing this, but if we go to the main activity, can we turn off the lights? Is it better? Okay. So there is another one. So the text view handle is called TV in this case, and there is a post method which works exactly like the run on the UI thread, which is on every element in the view hierarchy that you have, right? So you can post a new runnable into the queue using the post method of the UI element that you have. So I have a thread here. I'm executing kind of a separate background thread, which is just checking if the counter is maxed already. And if it's not, I'm sleeping and waiting for the counter to maxed. So I'm kind of doing a busy waiting here. And then if it's done, I'm updating the UI. So this runs in the background through the executors and uses the post, which is sort of an equivalent to the run on the UI thread. But here I don't need to have access to the main activity. I can do it, just having an access to the, and here we have the text view, right? So those are the normal ways of doing the update. If I delete those two lines and run the code just with this line, what will happen? Exactly. So let us try it. So I will kind of comment that and comment that, and if I run it. Basically what I'm doing here, I have, I'm spawning a couple of threads and they count up to the counter max. And this thread waits for them to finish and then updates some statistics on the, in the text view. So you will see in a moment. So the app still building. Yeah, so what should happen is I will have an exception, right? It will, and we will see the exception, and the exception will say, oh, you're touching the UI from the thread which doesn't have permissions to do that. Well, it is slower than usual because of the streaming. It will be good to have two laptops. Right, so while we wait, okay, it's ready. So it starts, it takes about, did it?
Application installation failed.
Oh, yeah. failed with the message. Oh yeah, I have to uninstall the existing app. Oh man, why? So threading, which one is it? This one? I can't read. Transitioned, web view, where is the threading? No, that's the one. Whoops. The fonts are quite. Oh crap. This one. Okay. Uninstall. Yes, I want this to be uninstalled. Okay. Please run. We need to see the exception, so I need to make it crash again. Okay, so it is uninstalling it, right? Hopefully. Okay, so is anything happening?
No, it's still error installing APKs at the bottom left of the screen.
Error installing. Okay, let's see again if I have it. No. Okay, I don't have it, so if I press run,
It's still failing. Top of the screen.
Okay. Well, I will sort of deal with that. So without the demo, it will crash, and it will kind of show here an exception saying you touching the UI from the thread that is not UI. So if I delete this and I run it from the post, it will be fine. Okay. So I have another activity which is doing basically the same thing. So it creates the new instance of the activity, and it prints in the log what thread I'm running in. And then it starts in the background a single thread, which I'm doing here. And it sleeps for 1 millisecond. It logs which thread I'm in. And then it sets the text without posting to a UI thread. Okay? And this one doesn't throw an exception. If I reduce that, if I make this more than 50 milliseconds, then it will throw the exception. But if it's very short sleep, it passes through. Okay? The question to you is why? So why sleeping here for more than 50 milliseconds causes the exception to be thrown, and having a very short sleep allows me to manipulate the UI from the background thread, which is not supposed to be allowed? What do you think?
Taking the lock properly, so it's preemptively starting the execution of the like speculative execution while it's checking if you're in the correct thread.
Yeah. So let's take a note. So some speculative execution. What else? What are the hypotheses you can set for this? I will try to fix the problem of this not building, but I need to move it to my screen so it will be easier for me to see what I'm doing. Yeah, restarting Android Studio. Usually it's just a sanity thing. I will re-import the, yeah, that was probably the reason. I need to projects. So what we're trying to do here is to understand why something is sort of unusual. And the unusual property is that according to the specs and according to the way you work with the background threads and with the UI on Android is that you're not supposed to touch UI from the background threads. And for some strange reason, when you execute this code and you say hello from a thread, it doesn't throw the exception. So we'll try to build it again. And one hypothesis is that it has somehow to do with the oh, you come on.
Didn't you get a red arrow text in the console stuff when you started? Or is that just from the...
No, that's
from the emulator.
That's from the emulator, yes. Okay, uninstall it. Unknown failure. Okay. Do we have it? Oh, we don't have it. No, we don't have it, right? No, we don't have it. And if we say, so let's do a clean. Let's rebuild the project from scratch.
You sure there's no...
So the uninstalling failed because we don't actually have it, which is okay. No, we don't want to close the project. Wait, I didn't click close the project. Okay. Rerun the app. Yay! Finally. All right, so as I told you, it kind of runs some counters in the background. It takes around 10 seconds to finish, and it kind of demonstrates, it says, okay, we've done the 100 tasks, but yeah, it kind of demonstrates that Volatile doesn't solve your race condition problems, and you can end up with an incorrect counter if you just use Volatile. So the first counter uses atomic integer to make the operations kind of atomic. The second one uses just volatile integer, and it always is smaller because two threads can be concurrently reading, incrementing, and updating the value, right? So if we say counter plus plus, and even though the value is set to be volatile, it can still happen in two concurrent threads. And it does happen 3 times, you see? 3 threads did update it at the same time.
Volatile doesn't fix the atomacy, it fixes the memory ordering issues.
Exactly, yes, exactly. And then we have the kind of rudimentary counter, which is also atomic, and it counts how many times people were trying to finish to do the job. Right, so when, because we have, I don't remember, we had, we're doing up to 100 jobs, and we have a thread pool of 8 threads, but we're starting 100 threads, right? So we have 100 concurrent threads trying to do the 100 jobs. So after the first job they've done, the second time the loop happens, the chance is that they are at the 99, right? And from this kind of stats, you see that most of them have seen the counter to be 99, and they tried to do this the one more time, but only one of them will be allowed, right? So 96 threads saw the counter to be 99, and they said, okay, I have to do the job one more time because only, we haven't finished 100, and one of them will continue, but the rest will kind of don't do that. So we will discuss it in a moment. Let's get back to the problem at hand. So the problem at hand is that if I click the start second activity, right? So if I say start second activity, I should have a crash. I click and I say, oh, hello from a thread. It's like, how is that possible, right? How is it possible that I can do that? And funny enough, if you increase that value to, let's say, 70 milliseconds, so let's sleep for 70 milliseconds and redo it, and go back here, go back to the main thread. It will restart the activity, yes, and I say, oh, come on, why did you?
I think you clicked the home.
Yeah, I did, yeah. So let's pick it again. So if I say start second activity now, boom, I have the expected exceptions, right? And it says, whoa, you calling, here it says view root caller from wrong thread exception. Only the original thread that created the view hierarchy can touch its views, right? Which is what you expect. So why does it work the very first time if I do it with a very short delay? So that's one question. The second question is, if I say here, wait for 1 millisecond, will I really wait for 1 millisecond? What do you think? Well, PMS knows it's not gonna happen. Why?
Well, I can't say exactly. I just don't think it will, because one millisecond isn't really that long.
Yeah, so let's redo it again. We open the app again. So if I start the second activity now, or not now, after it reboots, yes, it will say hello from a thread, right? So that's one question to you, like, why? Is it a vulnerability? Is it something to do with a speculative execution? Why? What would your hypothesis be of why it is happening? Of course, you can try to Google it, but before you try to Google it and solve it, you have to set some hypothesis. So why do you think it happens? Okay, the second question was, can I sleep for 1 millisecond? Okay, we can just try it. So I have here some tests in the main thread, in the main activity, and I actually did that. I said, can you, where is it? Can you sleep for 1 millisecond and tell me how long you were actually sleeping? So I'm using the system current time in milliseconds to count how long it takes from this moment to sleep for 1 millisecond, right? And we can run this. Okay, before we run it, so this one test I'm doing. The other test is I'm starting 1,000 threads. And I'm starting 1,000 threads by calling a new thread. So I'm, 1,000 empty threads which do completely nothing, right? It's just instantiating a thread and telling the thread, well, quit, do nothing, right? You are familiar with the lambda notation here in Java? So this substitutes the kind of a new runnable interface which has only one method. So you can shortcut it with the lambda expression. So I'm saying, okay, start 1,000 threads, do nothing, and quit. And how long does it take? And then I'm doing the same thing with the executor service. But with the executor service, I'm also starting a pool of 1,000 threads and counting how long this takes to execute 1,000 things on a pool of 1,000 threads, which do completely nothing, right? Which one do you think is going to be faster? Starting 1,000 threads which do nothing, or starting the pool with 1,000 threads and then running 1,000 empty jobs on it? What would be your hypothesis, yeah? Pool should be faster, or pool should be slower?
Yeah, that's a good question. Depends on what the Java compiler is allowed to do, I guess. So in terms of optimization and what you can see.
Yeah. So here we starting new threads with the job attached to it already, right? Here we're building a pool of 1,000 waiting threads. They don't do anything yet. We just have a pool. And then we can instantiate jobs on them, right? We can say, well, let's do those 1,000 jobs on those 1,000 threads, right? So let's see. Run the tests. Okay, so we have to create 1,000 threads. It took 1.1 second. The numbers are in milliseconds, right? So 1.1 second. To do it with the thread pool, a little bit faster, right? And then sleeping for 1 millisecond took 2 milliseconds, right? So there is a bit of an overhead, right? And with different languages, those overheads are different. I've done those things with Haskell, for example, and sleeping for 1 second takes almost 2 seconds. That's a little bit bizarre, right? But you can check for different languages how much the language overheads kind of accumulate. Here it's not too bad. Right, so is it surprising that the pool takes faster time than the... No, it's not surprising. Why? Because the Java VM knows more what you will be doing, and like when it instantiates the pool, it knows how to make it very efficiently, right? How to very efficiently optimize the creation of 1,000 threads in the pool. Whereas we are doing it very naively in a loop ourselves, and there is like the compiler cannot really optimize it, right?
Compiler should see that you're not actually doing that, and like that should be easier for the compiler to see in the naive solution than in the one using the library, because you're just parsing one file and you can see that that thread is not getting any information.
And I would expect
optimize away everything, all of that.
I expect C++ would probably do that. If you're running some empty loops in C++, the compiler will sort of optimize it away. Here it doesn't. It actually does it, right? And it takes almost a second 1.1 second to do that with the normal one, and 0.8 of a second with the thread pool. What is really interesting is if I say, well, I actually need to run those 1,000 things, but I will not do them on a pool of 1,000 threads. I will do them on a pool of, say, 100 threads, right? How long this gonna take, right? So if I say my pool, my pool is now, no, I think it's fine. Yes. So now my pool is now of only 100 threads. We reboot it. What do you expect those 1,000 empty jobs take on a pool of 100 threads? And I'm counting the time together with creation of the pool. So the second number is together with the creation of the pool, right? So let's do that again. So now with the normal threads, 1.3 seconds, a little bit slower than last time. Variation, like what is it, 10% or so error, no problem. With the thread pool, it took 81 milliseconds. Is it a 10-fold improvement now, right? And it's not surprising because I'm creating now only 100 threads, not 1,000. So it should take 10 times faster. And running the empty jobs, it's almost instantaneous, right? So that's what happens. Like the cost here is just the creation of the pool. The running of the empty jobs is really small. How small is it? Well, let's see. If I move the, if I don't count the time for creating the pool, I only count the time of running the 1,000 empty jobs on the already ready pool, right? So let's do that. Relaunch the app. Okay, the app relaunched, and I do it again. So let's scroll to the bottom. Come on. So 1.2 seconds for the first time. I think that might not. Let me kill it and rerun it again. So now the executor service initiates the pool, and then I'm taking the time of running the empty jobs and counting the end time here. So we're doing, let's wait for this to finish. Yep, and now I'm doing this. Okay, so 1.1 second again, and here 66 milliseconds. So creation of the pool actually is not that costly, right? It only takes about 20 milliseconds for this line of code to execute. And then the costly bit is this, is to run the jobs. And that might be because the thread pool might be doing it lazily, right? Instead of creating the 100 threads or 1,000 threads, it says, well, I know we want 1,000 threads, but currently I have no jobs to run. I will wait. And then when I said, okay, run the first 100,000 or 100 jobs, then it says, okay, I need those threads. So as I execute more jobs, it kind of instantiates more threads. So this first line is kind of a lie. It probably is a lazy instantiation of the pool. This line also is a bit of a lie because now it's busy instantiating the pool. And actually what I should do, I should measure it after, again, how long it will take to schedule those 1,000 empty jobs, right? So if I do that first, so let's take this and run it initially, and then measure the time if I'm doing it second time around. I should see an improvement. I should see, yeah, it's, maybe it will work. So let's see. Yeah, it actually restarts the app from scratch. We'll wait for the first test to stop. We'll run that. Right, took 2 milliseconds now, right? So scheduling 1,000 jobs on a pool that already exists and doing nothing takes almost nothing, right? 2 milliseconds is an error that I have when I sleep for 1 millisecond, right? So, you know, that basically takes no time at all, right? So scheduling 1,000 jobs that do nothing takes no time at all. Instantiating the pool takes, roughly speaking, 80 or so milliseconds, 20 in the first case with the instantiation of what the test showed the previous time. Okay, so now the volatile counter. So I have the volatile counter for the jobs, how many people finish the jobs, and that one tells us 96, 97, 99, because we have race condition updating that one. And the race condition is here when we say do some work and increment the counter. I actually split the job counter plus plus into 3 lines of code to show that job counter plus plus is actually a read operation, an increment operation, and the write operation, right? But the same race condition happens if I just say job counter plus plus. You will have exactly the same problem. And the problem is, as PMS said, that, yeah, so this is still a question, right? This is the, we come back to this. Now we talk about the main memory, and then the CPU caches, right? And the CPU, I have level 1 cache, really intimate with the core I'm running my stuff on. Then usually I have some sort of a level 2 cache which might be shared between 2 cores, right? And then I have level 3 cache. And if I need a value, if I'm doing some processing here and I need a value and I already have it in one of the caches, I will read it from the cache, right? And my counter is here. So my counter is in RAM, and it says something. Let's say it says 90, okay? But I have multiple copies. So let's say I have a two core setup, and I have the cached value in L1 cache for the one thread which runs here and one value which is here, right? Let's say they both read the value, so they both read the value and it says 90, but one of the threads kind of updated it, so in his cache, on its cache, it will say 91, right? So then I have inconsistencies because I have something in the cache which is not the same in the other cache, and it's not the same in the RAM, right? So in Java, I have a keyword called volatile, and I can say, okay, I want the counter to be volatile in such a way that any read always happens from the main RAM, and any write always pushes the value to the main RAM, right? So what does it mean? It means that I should not have this type of inconsistencies, because if this core needs to read, it will not read this value, it will read this value, but this core already wrote, so if this core already wrote 91, it doesn't store it only here, it pushes it to the RAM, right? So that means I always have kind of a consistent view of what's in the RAM, but it doesn't solve the mutual kind of access. And now both see value 91, and they both increment it, right? And they both can write it at the same time. So if I'm kind of at the same time incrementing it and writing, so, you know, let's say this one was just a little bit faster, updated it to 92, it goes into RAM, it updates it to 92, and this one is just a little bit later, updates it to 92, pushes it, and I have already 92, right? That's why this the second counter here is always smaller. This one, it's always smaller than 100 because it always happens that two threads did that, right? And in Java, that's it. That's the end of the story, right? How is the story in C++? Much richer, right? Why it's much richer? What's the reason why we have richer semantics in C++? Yeah?
Because that sort of memory isn't actually supported by all CPUs. So that's done in software in Java, and that's slow in general. Or like in platforms that can't support it in hardware, it's done in software.
Yeah. So the keyword here is performance. Performance, right? We paying the penalty. This model is very simple, and we only have one keyword, and it's sort of mentally kind of easy to grasp how volatile works, and that's fine, but you're paying the price. It's slow, right? If the performance is the key, well, you have to take advantage of the hardware, and you have to take advantage of some semantics that gives you that flexibility, right? For example, I might be quite flexible on, reading, right? I may not mind kind of reading inconsistent values or something like that. Or I might allow kind of, writes. So you have different options, and C++ kind of in very detail allows you to control of what synchronization semantics and memory access semantics you want to have in your program. Why do we talk about it? Well, we talk about it because you want repeatable programs, right? You want programs that actually achieve the same thing no matter what happens. So if you say, I'm kind of flexible, I know that there will be some sort of race conditions, but I can deal with it, then that's fine. But if you say, I cannot, I have to have this kind of consistency, then you have to pick the semantics that is aligned with your specification, with your expectations of what you need to do. Right, so with this one, not solving our problem, what are the potential solutions for solving the counting problem? So one is to use the atomic updates, right? So when I'm incrementing the value, like the problem here is that when I say counter plus plus, I'm actually doing two operations. I'm reading the value of three operations. I'm reading the value, incrementing it, and storing it. And I want all those three to be done as one, as a transaction, right? So using kind of an atomic integer solves the problem. And here we see using a kind of an atomic integer solves the problem. We have another problem though, because when we use, so for the jobs here, for the job counter, we use the atomic integer. We guaranteed that it will be atomically updated, right? So whoever is doing the job, when they update it, we know that we cannot have two threads kind of updating it at the same time, right? So that's fine. But when I'm checking it, so if I'm a thread and I'm reading the counter now, and it says 99. So if the counter says 99, I have to have a semantic which allows me to increment it and do my job without anybody else doing that at the same time, right? And with the atomic integer, you cannot really do that. You cannot lock, because if I have like, so what the threads are doing here, the threads will say, for example, increment and get, right? But two threads can do that at the same time, right? So how can I do a test that, yeah, let me make it to a background. Yeah, so here we're saying get the value and increment it, and if it is less than 100, do the work, right? But what happens when it's not less than max? We don't do the work, but we've already incremented the counter, right? So yeah, so with atomic integer, it's kind of tricky to do the if check, because if you check the API in Java for the atomic integer, it has the comparison test, which is atomic, but it only uses equality. It doesn't use less than, right? So I can do something if it exactly matches a value atomically, but I cannot do this test, kind of an increment atomically with the less than check, right?
So you're missing a compare and swap.
Yes. Yeah. So, and those are kind of nuances when you doing a different programming languages and different sort of systems, but it kind of gets, it gets quite complicated especially when you kind of hitting something unexpected like this one. Right, so let's have a 5 or 10 minutes break, and we will come back to it. Let's think again why this one is not throwing an exception, and is it a vulnerability? Okay. So the question remains: if you will find an answer to the question of why in the first 50 milliseconds I can manipulate the thread, let me know. I had a discussion with Simon about it because we were both puzzled. And our working hypothesis is that you have the instrumentation framework which monitors of what your threads are doing. And this instrumentation framework is bootstrapping at the same time as your activity is bootstrapping. And it's probably done, maybe not through speculation, but maybe in parallel. And it takes a little bit of time. And within that time frame, you can actually do things that are illegal because the instrumentation framework is not ready yet to monitor everything. It's not monitoring things, right? So when the activity is starting, the instrumentation is happening, and you're doing some illegal things before the instrumentation framework kind of kicks in. And because things happen in parallel. And then when this happens, then if you later than this instantiation happens, then you will be caught. You will say, well, what you're trying to do is illegal, right? So that kind of gave us a hint that what if other checks, other permissions are also kind of checked, you know, after the instrumentation framework is already instantiated. Maybe you can do some illegal things in the very early stages of the app bootstrapping because not all the checks are done yet, right? So that's sort of the potential avenue of checking, testing some of the vulnerabilities because you can try to do something that is illegal in a very early on stage. So that's one. The other one was, I will not play the video, but I will put the link into the lecture for you to check. Do you think it is possible to have a phishing app on your Android that you will not recognize that it's a phishing app? Let's say I will tell you, I'm gonna try to trick you. I'm gonna try to steal something from your phone, and you will run an app. Do you think you will be able to recognize that this app is doing something illegal or not illegal, like something that tries to circumvent Android security without you realizing it? Or do you think that that's not possible? I mean, if the app asks me for some permissions and I say no, of course I can see that and I will say no, right?
I think it's possible. My old phone, I think it will be especially possible because I have lots of stuff there because that was my development phone as well. So it was so much shit there. So when I use it, I'm sure I can do something there, but I'm not so sure on the new phone because I try and keep a bit more control there of what I have and what I give permission to.
Yeah. So yeah, let me just go here. I will find the lecture. So that came up towards the end of last year. So this one is yeah, so they have actually they make a page now, kind of a self-contained page with all the videos. Whoopsie. So I put the link into the lecture later. Have you heard about this vulnerability? So it is very interesting way of circumventing the permission system of Android, and fooling a person into doing something that they would normally not do, but they don't know what they are doing because they use overlays to kind of hide the real clicks that you're doing on the app, right? So it's sort of a very clever way of misusing the permission system of Android to trick a user into doing something that normally they wouldn't do. And they ran some tests on like security students and like IT people, and like nobody could tell that this was happening, right? So it's really hard to recognize it because you might have a game or you might have an app where you think you're doing kind of a normal thing, but at the same time the app is trying to leverage their privileges, right? So I encourage you to check this. I will not go more in detail today in the class. Like no point. You can watch it at home. They have some videos, you know, explaining exactly how it works and how it was possible to do that. And it also is interesting in some of the talks. I'm not sure if it is here, but in some of the talks I watched, they also talk about the process with Google of how these things have been addressed by Google itself. Whether Google considers it sort of serious or not serious, and how they're gonna patch it, and is it even possible to sort of patch it. And they propose some solutions, but they're quite difficult for Google to do. So we can spend some time later on discussing that once you learn about it. So this is sort of somewhat relevant to what I'm asking here, because you discover an anomaly of how certain things don't work as the spec says they work, and then because that was the same here, so the spec was saying that certain things should be certain way, and they discovered they are not, and that leads to a vulnerability, right? And they went back and forth with Google, and Google changed the specs. Right, so the vulnerability still stays. It's just that it's now consistent with the specs, right? Which is a bit bizarre way of dealing with the problem, right? Yeah. All right, so that's this one. The course we will have. So we have to set up the schedules for the. For the exam, and also we have to schedule the schedules for finishing the essays, right? So the preliminary date for everything to be finished is the last day of lectures, so it's Friday, 4th of May. We will sort of close the course. We will say, okay, no more submissions of any type. And no more reviews of any type. And that 14th of May is the first day of exams, and I set the oral exam for this one to be 15th of May. And I talked with Simon, and he said it's fine. So if there are no strong objections, we will have an oral exam on the 15th of May. We will talk about the exam later, but just the logistics and the date. Is it okay? Or do you have anything else already scheduled for 15th of May? If someone has any kind of problems with it, let me know, and we can sort of adjust it, but I think that will kind of work. It will give us, 11 days to wrap up and make sure everything has been read and checked. And for you, you will have, some time not doing anything for the course anymore, and then we have the oral exam. So that's one thing. The second thing is, let's say, where is the edit button? No. Yeah. So we have to have, so we have the first round done, but we should agree on the schedule. So how is it going with the second essays at the moment? So if I say So we are at when we are here. We're supposed to finish the second round in a week time, right? We said 2 weeks. So 23rd will be the end of the. So if I go here and make it a little bit bigger. So second essay finished by Friday, March 23. Then it will be Easter also, and we need some time for the reviews. So 6th of April will be the 2 weeks after that one, right? So 6th of April. Is it okay? Because that eats up the Easter time. Yeah?
I thought you said last week that the deadline would be the week after Easter for this.
Yeah, you did say that. It was Friday the 6th of April.
Right, for the second essay.
Second essay.
All right, so let's see if it works. So if we say April 6th, then we need 2 weeks. So that would be second essays, reviews, counters, Friday 20th. And then third, yeah, then we out of time.
Yes.
So we would have to do third essay finished. How many we have to do? We have to do 3.
3.
Yeah. So it would be fine. So if the final, the final is May 4th, right? So if we go back 1 week, 2 weeks back from May 4th. So that's March, May. So that's and April. So 20th, 27th. Yeah. So we can say the third essay finished by Friday, April 27th. Right? Yeah.
I was just thinking that maybe it'd be easier because when I looked at least the reviews, they didn't take that much time. So maybe it would be possible to say 2 weeks for the reviews and counter arguments, so then 1 week there, and then another 2 weeks for writing the essays instead. I don't know what people think about that because then you can move.
Yeah, I think that's better. We have a second essay for.
So shorten that time and say 20th here.
Yes, I think that would be better.
We can do that. So that would be 13th. And then until 4th, it's the final. Yeah, sounds good to me because then we can meet and have discussions as well. Although, yeah.
The third essay should be 27th. So we have 2 weeks for that.
That's true. So you have 2 weeks from the final reviews for the to do the essay, and then we can shorten that. So we can have. We could have a discussion on 4th, but that would be only 1 session. And those review sessions take longer. I mean, last time we only discussed like 1 essay in the whole session. So it would be good if we have a little bit more. So let's say the deadline then will be sooner than 4th. But it's only 1 week. Well, then we will not discuss the final ones. We will discuss the second ones. We will have time to discuss the second essays more, and the final ones we just discuss in the exam.
So no review for the final ones?
No, there is a review. You still have to review it, and the authors will get the reviews. We will not have a session discussing it, right? I think you should. It's valuable to have the final reviews.
Perhaps mark that down as well. The third essay reviews Friday, May 4th.
Yeah. Third essay reviews counters Friday, May 4th. All right.
Friday, not Thursday.
Yep. So then, okay, let me see. So next week we still not done, and then the Friday before Easter is off, right?
I don't think it's a whole day.
No.
I mean, can be off, but that's this Friday, right?
That Friday, not that Friday. This Friday is a Good Friday. I'm pretty sure it's off.
Yeah, that one's off.
Yeah.
I thought you meant
So this one is off. This one is not off. Yeah. But this one we cannot really discuss much because you're still working on your essays. So there will be no class next week, and there will be no class on Easter. And the first class is the Friday 6th. So you have kind of a long time now to beef up your second essays. Yep. So I will put the lecture 5, security and platform. So that's today. Next week, so Friday, March 23, no class, and then we'll have a class after Easter. So
yeah, it's
6.
7 after Easter.
So if you we cannot discuss your essays on 6 because you will be they will still have no reviews. So we have to discuss something here. And then on lecture 8 on 13th we can discuss the second round of essays because all the reviews will be done by then, right? So lecture 8 will be the second essay review. Lecture 8 review on April 13th. Yeah, for those review lectures, I kind of like you to come. For the lectures that we had like today, that I'm kind of presenting stuff and we have a bit of a discussion, if you don't come, that's okay. You can kind of watch on the stream. But for the review, those of you who are here in Jovik, I really encourage you to come and have a discussion, because if you're just watching on the stream, you're kind of not able to really participate. So for those please come. For those, depends. I mean, of course, I like you to come too, but you know, it's okay if you just watch on the stream as well. So for the streaming people, this is kind of okay. And this one, yeah, please participate. Okay. So we have this sorted for the oral exam. Okay, so I will save it. So have you started on the second essays or not yet? Is it easier than the first time round? Should be easier because you sort of know how it is. Not easier? Slightly. Not huge improvement?
Yeah, that's fine.
Yeah, so that bit might actually be more hard now because you're less naive of how to spec the topic and how to pick the topic. The process of writing itself should get easier the more you do it. And as I told you, like the essays 3 tend to be the best. You gain enough sort of experience and it's kind of easier to do that. Okay, so any suggestions what we should do for the topic after Easter? Anything kind of interesting? We could discuss a little bit more on the security, but I think the kind of the videos and lectures which they gave, they kind of cover it. There is, well, I mean, we can discuss it, but there is not much value which we can kind of add to it. What kind of interests you? What would you like to? Yeah.
Looking here, so looking at the topic on the course page.
Yeah.
It seems so. What I would find a bit interesting would be the legal framework stuff, or because that's something we need to delve into sometimes anyway. If we're going to develop here in Norman or you work for the things.
Okay, so that's one option. So legal frameworks and legal implications of publishing in different countries. With Google Play, it's not too bad actually, because they will do the taxation and things for you. But let's say you have a website and you're selling something, then you have to pay the VAT tax in each country the person made the purchase from. In Europe, it's like, how are you gonna do that? You have to track the IP, you have to have some sort of declaration of what citizens of the country they are. But for example, let's say you're a citizen of Norway and you're driving through Germany to France and buying some sort of a guidebook about France, which is published in Poland and sold from Polish website, right? You're currently driving in Germany, buying the Polish book from a Polish company, but you're a Norwegian citizen. Where you pay the VAT? In Norway, in Germany, or in Poland? And you actually need to pay the VAT in Germany, right? So it is pretty complicated. With Google Play, okay, no big deal, because you will be doing a purchase through Google Play and the Google will handle it somehow. I mean, it's Google's, you know, responsibility to do it right? If they do it wrong, it's kind of their fault. But they usually do it right, and they will, you know, the customer will pay. They will pay the VAT to whichever jurisdiction they have to, and you will get only the amount without the VAT already, right? The VAT will be paid. So that's kind of a bonus. So what was that? Legal frameworks and implications. What else?
Maybe we can discuss, is it worth it to go to learn progressive web apps or similar concepts which are in application between websites?
Yeah. So progressive web apps, mixed models. Yeah, that space is super hard because it evolves really rapidly and it changes very rapidly as well. So if we go back like 3 or 4 years ago, it was quite crap actually, right? So a lot of companies tried to do some sort of progressive or hybrid apps, and they were most of the time not good enough. They had to rewrite them in native eventually, right? So a lot of companies tried it, they failed, and they rewrote everything from scratch in native mode anyway. But you know, fast forward now, the frameworks and the capabilities are getting solid. They actually good. And you know, fast forward a bit into the future, they probably will be the better solution, which allows you to kind of cross the boundaries of the devices and so on. So it is an interesting topic, but it's hard because it's not something kind of stable. It's very a moving target topic. But yeah, that's a good suggestion. What else? What else you find interesting or fascinating to discuss in the class? Yes?
Public key infrastructure on SIM cards.
Okay. Infrastructures on SIM cards. That's pretty cool. That's pretty good. Kind of a little bit related to that is the evolution of the GSM networks. That, you know, the 5th generation, what it brings, what sort of, you know, people just think, okay, it's speeds and so on, but it's not only that. It's a lot of this stuff as well. There has been kind of an interesting research done on SIM card-less mobile phones. Can we get away without SIM cards now? Like, why do you need a SIM card, right? Can we have this sort of a secure element on the device itself and have just some sort of a digital exchange which distributes the IMEI numbers and things kind of digitally, right? Because that would simplify life enormously for companies. Right now, you have to buy this kind of a physical item. Like, why do I need this physical item? Well, because, you know, it has this sort of a certain security elements, right? But can we kind of get rid of it? Can we have all those security guarantees by having some sort of a distribution system where I can download my SIM card from the provider? I go to Telenor and say, I want to buy a phone. They say, yeah, you can download the SIM card, right, to your phone. Yeah, that is a good one as well, and it's sort of again quite challenging, like because it's new. Cool. All right. So if you have some suggestions, you can edit. I will try to prepare some papers which we can read before the class and discuss. Maybe not all the topics, but like maybe at least 2 out of 3. Cool. Any questions?
Will there be 2 weeks now without lectures?
There will be 2 weeks now without lectures because the next week I canceled and then the following week is Easter. Yeah. Cool. Great. So that's it. We finished before time today for a change. This is like amazing.